Hello and welcome to York Observatory's weekly TeleTube broadcast, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. We are broadcasting live from the Alumni Carswell Observatory located at York University in Toronto, Ontario, Canada. York YouTube broadcasts every Wednesday night at 7:30 p.m. local Toronto time. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle at York Observatory and Facebook at Alumni Carswell Ops. Good evening, everyone. I'm Maheen, and I'll be one of your hosts this evening, along with Mariana, Dorsa, and Nicole. And we're here from the Alumni Carswell Observatory at York University. Tonight, we will be talking all about the recently discovered and currently visible from the Earth, the Green Comet. Before we get further into our show, I would like to mention that the observatory at York campus is in Toronto, and we would like to welcome you all to our show and to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Takaranto has been taken care by the Anishinaabe Nation, the Haudenosaunee Confederacy, the Huron-Wendat, and the Métis. It is now home to many Indigenous peoples. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. Our stargazing and astronomical efforts join the long history and current practices of astronomy for this land. The observatory looks forward to continuing to learn and revitalize our knowledge in this area. But before we get into our main show, we would like to give you a little update on what you can see this coming week. The moon is currently in the waning gibbous phase with an illumination of 91.1%, which does make it hard to observe less bright objects in the sky, but there's still a lot that can be seen. It is, however, a good opportunity to observe the moon itself. The three stars in Orion's belt are bright enough to be observed even with the moon being so bright. This star system is known as the Mintaka system and is a part of the Orion constellation, and therefore fairly easy to spot in the night sky. The most easterly of the three stars is the Alnitak, also known as Zeta Orionis. When this star is seen in a telescope, it can be seen that it is actually a double star with a magnitude of 1.85. Alnilam, also known as Epsilon Orionis, is the middle star and more than twice as far away than the other two stars. The star on the western side is the Mintaka, also known as Delta Orionis, which is a double star as well, but is widely spaced. Binoculars can be useful when viewing these stars. Since this teletube is about the Green Comet, it is worth mentioning that on the night of February 10th, the path of comet C22E3 ZTF will carry it to be close to the planet Mars. They will nearly be overhead in the southwestern sky and a great sight to view through binoculars. The comet is no longer easily visible with the naked eye, but binoculars can come in handy when observing it. The open star cluster Pleiades, also known as Messier 45, is high in the southwestern sky in mid-February during evenings and can be really enjoyable to observe. So keep an eye out for that. On February 14th, before dawn, a waning third quarter moon will be visible only a several finger width to the upper right of the star Antares, which is the brightest star in the constellation of Scorpius. I will now hand it over to Mariana to get us started with our show.
Thank you, Maheen. Now, before we get started talking about the amazing green comet, also known as C-2022 E3ZTF, let's talk about what comets actually are. Comets are usually depicted as big, fiery spheres that fly through the night sky in comics and in TV shows, but that couldn't be further from the truth. Comets are composed of rocks, dust, and ices that are frozen together and are from the formation of our solar system. Comets are basically cosmic snowballs and can range in size and be as large as a small town. Now, they range anywhere from around 1 kilometer to around 10 kilometers in size and are extremely cold. Comets orbit the sun with highly elliptical orbits and can spend hundreds or thousands of years just completing one orbit. Now, with this being said, there are two classes of comets, the short period comets and the long period comets. Their names are pretty self-explanatory. However, we must keep in mind that the astronomical time is understood differently. So for short period comets, their orbits around the sun take around 200 years or less. And that's not really short at all. But long comets, their orbits take over 200 years. So in general, comets are highly unpredictable objects since their brightness depends on the scattering of light from the dust particles in the comet's coma and tail. To break it down, comets have a nucleus, which can be thought of as like a core and is essentially the entire comet. The coma is the dusty atmosphere surrounding the nucleus, which is made up of sublimated gas mixed with dust. The coma is reasonably large and is separate from the tails due to the strong solar winds that come from the sun. Now, if you take a look at the image on the slide, you can see that the comet has two tails. The first tail is the ion tail and is made up of ionized gas, and the second tail is a dust tail, and that is made up of small solid particles. The reason that comets have these tails is because its orbit brings it closer to the sun, and so the comet heats up, and as it heats up, it spews gas and dust. The ion tail points away from the sun, while the dust tail is slightly curved behind the comet as it travels in its orbit. The strong solar winds also force the optical illusion that makes these tails appear on both sides of the nucleus. When the comet is glowing, it could be brighter than some other objects in our night sky. That is, if it's visible from Earth, of course. Now that I talked a bit about what comets actually are, let's talk about the green comet that's in our night sky. So Comet C-2022 E3ZTF, and its funny name does have a meaning. So the C stands for non-periodic comet. And the reason that this green comet has this classification is because its orbital period is around 50,000 years. So you don't want to miss this in our night sky because it will not be coming back in our lifetime. Now the E3 in the name tells us that the comet was the third comet that was discovered in the first half of the month of March in 2022. Hence the 2022 in the name as well. This comet was from the Oort cloud and was discovered by the Zwicky Transient Facility on March 2nd, 2022, which gives reason for the ZTF that's in the brackets of the name. This classification is used for all comets, and it gives astronomers a way to recognize certain comets and helps them provide important information within its name. So how was this comet discovered if its orbit is 50,000 years long, you may ask? Well, the astronomers at the Zwicky Transient Facility discovered the green comet using the Wide Field Survey Camera. The Wide Field Survey Camera at this facility scans the entire north sky every 2 days, and this helps astronomers pursue a broad range of time domain science. This includes asteroids and comets, of course. This comet has grown brighter in the sky since they discovered it, but it is still pretty dim compared to other bright objects in the sky like the moon. So this comet was the closest to Earth and the brightest that it would be in our sky on February 1st to February 2nd, just last week. However, using a small telescope or a large telescope like the 1-meter telescope at the Allen Cosmo Observatory, this will really help find this beautiful object in the night sky, and you can capture really nice images with it as well. Now that we've learned about what comets actually are and why they have such silly names, I would love to pass it to my friend Dorsa so she can tell you more about this fascinating green comet.
Thank you, Mariana. Hello, everyone. We hope that you have the chance to see this beautiful comet so far, but if you still haven't had that chance, no worries. The green comet will still be around only for a few more days, and if weather permits, you might be able to still see it from 10 p.m. EST onwards. If you still can't see it, we've got you covered. My colleague Nakul will get into more details about this later, but as of now, I would like to talk a bit about the discovery of this comet. As Mariana has mentioned, the actual name of this comet is Comet C 2022 E3 ZTF, and it is actually a quite recent discovery for a comet. It was discovered last March in 2022 when it was already inside the orbit of Jupiter, making its way towards Earth viewing, where it is currently orbiting around the Sun. The green comet was discovered on March 2nd at California's Palomar Observatory by using artificial intelligence to evaluate photographs of the entire night sky. This rare comet was discovered by astronomers Bryce Folan and Frank Moschi using what's called the Zwicky Transit Facility Telescope, ZTF, which is a telescope that takes hundreds of deep space pictures per night. On March 2nd, 2022, Bolin hopped on his walking desk and activated the system to detect comets as his nightly ritual, of course, at the observatory where he took a deep look into the space using ZTF. And after hours and hours of analyzing data outputs, the system that he set up was creating a set of 5 images of the telescope's field of view per se. And as mentioned in his interview, Bolin said that this system noted an 80% probability that it had identified a comet. He said that even though they use AI for identifying comets as such, he, as a human being, has the final say to whether what he was looking at was a comet or else. With the 85% probability of the system noting and what Bolin researches every day, there was no doubt that the object that he was seeing could be either a comet or an asteroid. After his analysis and the pictures being taken, he did not want to make any announcements just yet for the sake of reassurance that it was indeed a comet or not, also a comet that no human has ever seen before. This green comet had a previous journey to where it is right now around 50,000 years ago, so it is truly a great discovery that humans can make in order to find and observe celestial objects as such. Bolin contacted the Minor Planets Center for the International Astronomical Union, requesting another telescope to collaborate his data with astronomers, confirming his findings and actually confirming the coma that Mariana talked about, or a combination of dust and gas that in turn makes a comet. A week later of his discovery, Bolin made a public announcement about Comet C22E3 ZTF, with the C identifying that it is not a periodic comet, and the 2022 E3 saying that it was the third comet to be discovered in the first half of March 2022. Moreover, the non-periodic characteristics of this comet signifies that it takes over 200 Earth years to orbit the Sun. According to EarthSky, this icy celestial object made its closest approach by Earth between February 1st and February 2nd, 2023, around 42 million to 44 million kilometers away. Even during its closest approach, the green comet will still be more than 100 times the moon's distance away from Earth, in turn pointing out its distance to us and why it took so many years, so many ages to get to Sun's orbit. Moving on and going towards its color, the reason why Comet C2022E3ZTF is called the green comet for short is due to the complex carbon chain molecules that are destroyed by the sun's light and broken down into simpler carbon diatomic molecules, giving rise to the green aura. This distinct color is really influenced by that diatomic carbon present in the comet's head, which interacts with solar radiation as the object travels through space and throughout the journey around the sun's orbit and back to the Oort cloud. According to the Washington Post, the reason why comets like this are very important to astronomers in general is because they are classified as prehistoric relics, since they were formed in the very early history of the solar system, as Bolin would say. Long period comets were the celestial objects that in turn, they were the very first celestial objects that brought organic compounds to ancient Earth about 4 billion years ago. And it is due to these comets that we can say that Earth has its abundant life, again, as Bolin said in his announcement. I will read a sentence or two of what he mentioned about the comet's importance, quoting that we know that it has to be kind of like a time capsule of the conditions in the solar system around the time of its birth. So it is kind of so it kind of preserves like a record, legacy of the solar system and the kinds of chemical compounds and even the precursors of life itself. Through many observation nights, including observing sessions at the LMI Cosmo Observatory, we can say that this green comet is distinguishable from other objects and stars by its streaking tails of dust and its energized particles alongside its glowing green coma surrounding it. Lastly, it is not only the pretty green aura that attracted millions, especially astronomers across this world, towards this comet. Its brightness, caused by its distance from us, permits us to utilize spectroscopy to measure gases that are emitted from it. The reason for why this is so important in the science community has to do with detecting molecules like chloroacetophenone and hydroxide as examples, since they can give us clues about the amount of water or ice on the comet. Mike Kelly, an astronomer of University of Maryland and a comet expert, said that by studying the process of cometary change, we can work backwards to what the original composition of the comet was and get a clue about the early solar system soup. Hence why this comet gathered so much attention to itself around the world. Well, folks, I hope you have enjoyed knowing these facts about the Green Comet. I will now pass this presentation on to Nicole, my colleague and friend, who will talk a little bit more about the comet's observations, both in general and at our observatory. Nicole, take it away.
That's so amazing, Dosa. And hello, everyone. We actually got an opportunity to observe the green comet with a 1 meter telescope at our observatory, as you see on the screen right now, and capture some cool pictures of the comet. The live observation which we are seeing right now was happened on February 1 after the sunset using the Mancam of the 1 meter telescope and streamed live to our Yorkie Observatory YouTube channel. Make sure to check it out later. The green comet was also observed before the early morning of Jan 15 at the observatory. The comet was visible in the area of North Sky, right near the pole star Polaris, from January 12 to the first half of the February. Astronomy apps like Stellarium would guide you well with the time and direction to observe the comet. You also need a pair of binocular or telescope to view this object, and it's not bright enough to observe through the naked eyes until it peaks on February 1 and February 2. Make sure to observe this object where the light pollution is less, and also the brightness of the moon over the sky might also affect the observation of the comet. The comet hailed from the outskirts of AICO, which is the outskirt of the solar system. It was moving in the east direction across Hercules and Corona Boreas until January and shifted towards north direction across the constellation Draco, Ursa Minor, and Camina Fatalis until 23rd Jan and moves towards northwest direction. After the after the across the constellation Auria and Taurus, it made the closest approach to the sun on January 12, coming within 170 million kilometers to the sun. If you are interested to image the comet, an exposure time of 30 to 60 seconds is recommended, and it's safe for most of the telescope with a focal length around 300 to 700 millimeter. Comets are ball-point object, and it can be photographed with a simple DSLR camera or a one-shot camera without filters, and if you are using a monochrome camera, RGB filters is enough. The comet can be captured using a DSLR camera with a tripod. It can be easily captured since the comet is large and the bright for the camera lens to get it. Now we are going to keep this video playing for some minutes before wrapping up, and if you have any questions, feel free to ask us on the comment section.
Well, everyone, you have been listening to the ALI Cosmo Observatory's weekly TeleTube broadcast, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Maheen, Dorsa, Nicole, and myself, Mariana. Make sure to leave any comments or questions in the comment section of the video and talk to us in chat right now. We'll be around for the next 20 minutes to answer all of your questions. All of our programs are free, but if you'd like to make a donation, see our website at yorku.ca/science/observatory. You can always connect with us on Twitter with the handle @York Observatory and check out our website for show notes, content, update, and contact information at yorku.ca/science/observatory. Thank you for tuning in. Clear skies and have a great night.